Hey everybody, excited? I know I am. We're going to start talking today about 3.2. I know you're super excited for this lecture. I'm sorry we can't be together to do this. A lot of what we're going to do here in 3.2 should be review. So I'm not going to do a whole lot. You just did it in 930, so I'm not going to basically what I want to do is a bunch of examples, okay? So we're going to look at a couple things. As you can see from the title, quadratic equations, functions, zeros, and models. So 3.2 and 3.3, we're really going to look at quadratic equations and functions. So remember, a quadratic equation is an equation of this form, right? This is a quadratic equation, and a quadratic function is basically just the same thing, but with function notation. And this is all where a is not 0, because if a were 0, that'd be silly, because the whole reason it's a quadratic is because it's a polynomial of degree 2. Okay, that is the important thing about what a quadratic is. Okay, so when we solve, we're going to look at solving quadratics, and we've already been doing this because we've been looking at domains of functions with fractions and where we set the denominator equal to 0. So I don't want to spend too much time talking about, solving while factoring. Let's do one quick example. If I can factor something, of course, I would want to try and solve something that I know I can factor. I want to solve it by factoring. So, we know we can do this. We get x minus 1 times x minus 2 equals 0. And then from there, I set each one equal to 0. This, if you look in your book, which this is true, this is the principle of zero products, meaning if one is 0, or excuse me, if I have two things multiplied together to be 0, this one's 0 or this one's 0, means they can both be 0. That's fine. And so we get two solutions. So we know how to do that, right? We know how to solve by factoring. And this is the preferred method of solving. Like when I go to solve a quadratic, I want to make sure, hey, does this factor? That's the first thing I look at. Can I factor it? It's way, way easier than the next two methods that we're going to look at. So there are two methods I want to look at in this section: completing the square to solve, and I want to look at the quadratic formula, which you've heard of, and then we're going to look at some application problems. So first, completing the square, which you should have done in 930. So I am just going to do a bunch of examples for you. Where's my watch? So this is what you'll see on the test. Solve by completing the square. I will tell you to do that. If I just say solve, then you are welcome to try, and you are welcome to use whatever method you want, right? If I just say solve the following equation, then you can try and factor it, you could do quadratic formula, you can do whatever you want. But if I tell you to solve by completing the square, then you need to solve by completing the square. All right, let's look at a simple example. So x squared plus 4x, let's say plus 1, equals 0. So when we look at solving by completing the square, the first step we want to do when we're solving by completing the square, first step, that was supposed to be a different color. First step, okay, is make sure that there is a 1 in front of x squared. Okay, so I want a 1 in front of the x squared term, which right here we have, so we're good to go. Our second step, if there isn't a 1 in front of that x squared term, what I want to do is divide by everything. Second step then is to get x's on one side. Okay, so in this case, I want to get all my x's on one side, so I'm going to subtract this 1 from both sides. So I have x squared plus 4x equals -1. Okay, so my x is on one side, and notice how I left a space here, so you'll remember that from completing the square in 930. Get x's on one side, then remember we take take half of b, right? Square it, and add to both sides. All right, this is the actual, both these sides. This is the actual process of completing the square that makes the left-hand side a perfect square. And again, I'm not going into a lot of detail on why it works, because you should have talked about that with Neil. So I'm going to take half of the middle term, half of 4. This is what I always do. Half of 4 is 2, and then I'm going to square 2, right? So 2 squared is 4, and so this is the value that I add to both sides. Remember, what you do to one side, you better believe you're doing to the other side, okay? Once I have added that 4 to both sides, this is the magic, people. This is the magic. This side right here now is a perfect square polynomial, meaning you can factor it as a perfect square. That is why you added that 4 to both sides, because when we factor this now, this becomes x plus 2, right? Quantity squared, right? Two numbers, whoops, that multiply to be 4 and add to be 4. That's 2 and 2. And on the right hand side here, I get 3. Okay. Oh, I forgot my little list here. So half of b, square and add to both sides. Then you want to factor the perfect square trinomial. So just factor that perfect square. Okay, and solve. Those are the steps for completing the square. Those are kind of really fast steps. But once I have it in this form right here, now I can solve it. Whereas up here, I couldn't factor it, and so I couldn't really do anything. I have two terms with x's in them, so I can't isolate x because one is squared and one is not. So what we do is this method of completing the square. Now, what are we going to do? We're going to square root both sides, making sure we bring in the plus or minus. So I get plus or minus the square root of 3, which we just leave as the square root of 3, which is fine. And then the last step is to subtract that 2. So my answers are x equals a negative 2 plus root 3, and x equals a negative 2 minus root 3. And I can hear you guys right now. Sarah, but can I just write plus or minus? Yes, I am fine with you writing plus or minus. However, of course, my math lab is not. So in my math lab, you need to state each one, which I kind of understand why they do that. They want to make sure you understand that, that there are two solutions here. Again, what did I do here? I subtracted 2 from both sides, and then we just usually put the square root after that 2. So I have a negative 2 plus root 3 and negative 2 minus root 3. If you've done anything with discriminants, well, we're not really going to do much with discriminants, but the type of solution that I have here is I have 2 irrational solutions to this guy right there. All right, let's do some more, because that is how we get good at math, is we do more. Solve by completing, I'm getting lazy now, the square. Okay, so what if we had 3x squared, sorry about that. You're looking at my blackboard there, didn't mean to do that. Let's say 3x squared minus 6x, I don't know, plus, let's say 30. No, I don't. Yeah, that's fine. Equals 0. Okay, so again, if we look back at our steps here, we need to get a 1 in front of the x squared term. That is always, always, always your first step. So what I'm going to do is divide everything by 3. Okay, all sides of the equation, I'm going to divide it by 3. So we get x squared minus 2x plus 10 equals 0. Now, what was my next step? If you look back, I want to get all my x's on one side. So I am going to subtract 10 from both sides. Okay, now again, what's my next step? I take half the middle term. The middle term is a negative 2. That is a negative 1. And then what am I going to do to that negative 1? I'm going to square it. So what am I adding to both sides? I'm adding a 1 to both sides. Okay. Now that you've added that 1 to both sides, this right here is a perfect square trinomial, which means it factors into, what I mean by that is if I were to factor this, I would take x, right? And x, I need two numbers that multiply to be 1. That's 1 and 1. Add to be negative 2. That's minus 1 and minus 1. Little hint here. This number right here is always going to be correspond to this number. So half that middle term, whenever you factor it, always, 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 if it's after you've done the perfect square, completing the square, once you've done that, again, it always factors into this number right here with your x. And this right here takes on the same sign as this. You can always FOIL that out and make sure this is what you get, and that shows you that you did the correct factorization. What do I get over here? -9. Oh, this is going to be fun. -9. Now what do I want to do? I want to square root both sides. So I bring in my square root. I bring in a plus or a minus. Anytime you bring in a square root that is not there already, you must bring in a plus or minus. All right, people, this one's fun. Because look at what I have. I have plus or minus the square root of a -9, which is the same thing. Square root of -9 is 3i. So this is plus or minus 3i. Remember that negative sign there becomes my I. Square root of 9 is 3. Final answer, I need to add 1 to both sides, so I get 1 plus or minus 3i. So my two solutions are 1 plus 3i and 1 minus 3i. Hope that makes sense. Okay, so I have two complex solutions if we're talking about the type of solutions that we have. I want to do another one, and we'll do what I want, because you are stuck to the mercy of this recording. And I love it. So, all right, so another example, let's do one. Yeah, let's do one. I think we should do one with a fraction. Don't you think we should do one with a fraction? Totally agree. We should do one with a fraction. So what if I had 1/5 x squared, again, solve by completing the square, blah, 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 minus x equals 0. Okay, so my first step, remember, is I want to get a 1 in front here. So I could divide by 1/5 if I wanted to, but that can always be a little bit weird. Not weird, but, oh, whoops. Sorry about that. So what I'm going to do instead is I'm actually going to multiply everything by 5 because I'm dividing by 5. So what's the opposite of dividing by 5? I might as well multiply by 5. I didn't do that on the last one because I wasn't dividing by that number. I was multiplying by it. Nope. 5 times 1/5 is 1. So I get a 1 in front, minus 5x equals 0. And I'm giving myself some room because I don't have any constant terms, so I don't need to do anything there. I don't need to move anything else over. I already have my x's by themselves, okay? So again, completing the square, I'm going to take half that middle term, which is a -5/2, and I'm going to square it. You guys do not need your calculator to square this. Put your calculator down, people. All right, so what do I do to square this? It becomes positive. I get 5 squared is 25, 2 squared is 4, and then don't forget, golden rule in mathematics, what you do to one side, thou shalt do to the other side. All right, so this guy right here, again, is a perfect square trinomial. It takes on the same sign as this -5 here. So I'm going to have x minus, and then remember, it's always this number. It's half that middle term. Because when then you FOIL it out, when you these two are going to multiply together to get this number, and then it's going to add to itself to get 5. So half of 5 plus half of 5 is a whole 5. Okay, so I get 25/4 on that side. All right, now let's square root. So I get x minus 5/2 equals plus or minus 20, the square root, excuse me, of 25/4. But this, my friends, is a perfect square, right? So look at what we have here. We have plus or minus 5/2. So when I solve this, be careful about getting too comfortable with this plus or minus. I'm going to add 5/2. So I get 5/2 plus or minus 5/2. That's not our solution. We can go further than that. It's not irrational. It's not complex. So we can actually simplify this. X is going to be 5/2 plus 5/2 and 5/2 minus 5/2. So 5/2 plus 5/2, again, that's half of 5 plus half of 5, so that's 1 whole 5, or 10/2. And then 5/2 minus 5/2 is 0. So x equals 0 or 5. And you probably saw that. I mean, we could have, even here, I could have just factored this, but I said to solve by completing the square. If I were to really solve this, like if I was out, you know, quick, Sarah, solve this quadratic, because that happens all the time, I would have factored it, obviously, but I'm just testing your knowledge on how to complete the square. Okay, good. I like it. The other method that we can use is the quadratic formula. I would really sound it out. Is that how you spell it? Yeah. I would love to prove this for you, but I feel like if I start proving this for you, you guys are just going to turn off this video and you will never finish watching it. So, quadratic formula, opposite of b plus or minus b squared minus 4ac all over 2a. This gives you the solutions to the equation ax squared plus bx plus c equals 0. Okay, that gives you the solutions to that equation. And the way you prove this, if you look in your book, I'm sure you all are going to go to your book on page 179, they prove it for you. They take this equation right here and they solve it by completing the square with the a, b's, and c's. It's pretty awesome, I have to tell you. You should go read it or come by my office and I'll prove this for you on Monday. All right, so this is the quadratic formula. So how do we use this? Well, we just follow, this is the rule. And so if I had like 2x squared minus 3x plus 5 equals 0, and I'll say solve using, I'm getting really lazy, the quadratic formula. So what do we know? We know a is 2, b is -3, and c is 5, right? And I just put it in here. You got to know this formula for the test. I will not be giving it to you. Quadratic formula comes up so often that it's something that you need to memorize. So, all right, look at what this is saying. Negative, or the opposite of b, plus or minus the square root of b squared. You must have that negative in parentheses, people. Minus 4 times a times c all over 2 times a. All right, so let's start simplifying this a little bit. So I get opposite of -3 is 3, plus or minus, I'm going to get, what do I get here? I'm going to get 9 minus 40, I think. Ooh, we're going to have, this is pretty fun. We're going to have complex solution. So I get the square root of -31. Whoa, that was awesome. There we go. Plus or minus the square root of a -31 all over 4. Okay. Just pick a different color. I think I did. It's very subtle, but all right, and so what do we get here? 3 plus or minus. I don't want to leave that negative under the square root, so remember the negative just comes out as I, and I just get 3 plus or minus I root 31, and I'm done. Okay. 2 complex solutions. Let's look at one. I'd like to look at one more of those. Whoops. I just want to look at one. Let me make sure I have one where I want to show you one where stuff kind of simplifies. Yeah, let's look at this one. Okay, solve using the quadratic formula. Again, how about we have something like this? Okay, so I have this quadratic, 3x squared equals -2x plus 7. Well, if you notice in my quadratic formula, right, I can only use it if it is of, my quadratic is in this form, where it's set equal to 0. So I get 3x squared, I'm going to bring the 2x over, bring the 7 over, set it equal to 0, and now we're in the form that is useful. So b equals 2, c equals -7, plug it in, opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so look at what we get here. I have x equals then -2 plus or minus the square root. Let's see what happens in here. All right, so I get 4, and then this is 12 times 7, I think is 84, or 21 times 4 is 84, but there are 2 negatives, so that becomes a positive, so that'd be plus 84, right? So that's 88. So square root of 88 all over 6. Now, people, you may not cancel the 2 and the 6. I know you want to. I know they share a common factor. I get it. The problem is this 6 is not just dividing the 2, the 6 is also dividing this stuff over here. We can simplify this a little bit though, so have no fear. This is what, 4 times 22, right? And 4 is a perfect square. So I can rewrite this as -2 plus or minus 2 root 22 over 6. I'm not completely simplified yet because I could take a 2 out of the numerator, right? And now, my friends, I can cancel this 2 because it's all multiplication. Okay, so my final answer then, because I'm not canceling across addition and subtraction, subtraction, I'm canceling across multiplication. So my final answer, -1 plus or minus the square root of 22 all over 3. Lovely. Love it. All right, and then the last thing I just want to talk about, if you're still with me, hopefully, it's only been about 21 minutes, so that's not too bad, is I would like to do an application problem. Okay, so I'm just kind of taking this one from your book. You want to make sure you do the fun sheet. I'll post the solutions to the fun sheet online so that you can look at those. But let's look at an application problem here. How about this? One leg of a right triangle. So of course the application problems can be tricky, right? I get that. So we're going to take this step by step. One leg of a right triangle is 7 centimeters less than the length of the other leg. I'm just going to put the other leg, you get its length. Okay, of the other leg, the length of the hypotenuse. So if the hypotenuse is 13 centimeters, find the lengths of the other legs. Sorry, my handwriting is a little sloppy. Okay, so one leg of a right triangle is 7 centimeters less than the other leg. If the hypotenuse is 13 centimeters, find the lengths of the legs. Let's draw a right triangle. Pretend that this is a right triangle. All right, and let's label this guy. So if this is 13, right, and let's say this is x, one leg of a right triangle is 7 centimeters less than the other leg. So if this is my one leg, this guy is 7 centimeters less than that. 7 centimeters less than that leg right there. I hope that makes sense why I have that x minus 7. So draw a picture if you're not sure with these application problems. See what's going on. If we have a right triangle, of course I need some way to relate these together. So how am I going to relate them? Using the Pythagorean Theorem. So I'm going to take the sum of the squares of the sides. And I know you can figure out what the answer is here. I get that. But you need to use calculus and you need to use quadratics to solve this. If I FOIL this out, I'm going to just go ahead and FOIL it in my head. You can verify that I FOILed it correctly. Equals 169. Okay, and so now I'm combining like terms. I have 2x squared minus 14x. I'm going to subtract the 169. So I would get a negative 120, I believe, equals 0. Now I have a quadratic to solve. So we have 3 ways to solve these, right? I can factor it, if it's can factor. I can complete the square, or I can do the quadratic formula. I'm going to try and factor. Let's divide everything by 2 first. Might as well. I mean, I could factor it as is, but why not divide it by 2 to, you know, make your life a little bit easier? All right, and so I have 7x and 60. So I need 2 numbers that multiply to be 60, add to be 7. So I think our winners are 12 and 5, minus 12, plus 5. So what are my options for x? 12 and negative 5. I'm going to throw out that negative 5 because that doesn't make sense for the length of a triangle. So one side of the triangle is 12 centimeters, and then it's funny because that 5 comes into play anyway. Now, what's the other side? I just subtract 7 from 12, and I get 5. And then I put a pretty little bow on it by writing it out in a beautiful sentence. Okay, I hope this is making sense. You need to make sure you look over the fun sheet. You need to email me if you have any questions. I haven't done an example of every single application problem. I need you guys to start trying some of those on your own so I don't have to set those up cookie cutter for you every single time. But if you need a little bit of help or need a little bit of a nudge on which way to go, please make sure that you email me or come and see me on Monday, right? And bring questions to class on Tuesday. Well, that was a good time. I hope you guys had fun too. Thanks for watching.